What I'm going to talk about this morning is what I like to refer to as top band. It's the lowest of the gigahertz bands. It's a rather large band, and I want to try and get rid of some of the myths and the magic that's associated with the gigahertz bands, because people see them as a little bit scary sometimes. Some people say, what's the point? But I'm going to look at what you're likely to work. How does it compare to, say, 2 meters or 70 sems? What's the same? What's different? And things like that. So that's the sort of topic. And I'm going to cover one thing that I think is probably the most important on these higher bands, system engineering. We've some people come from an engineering background, some people don't. But once you get onto these higher bands, you've got lots of different challenges than you might have on 50 megs or something like that. So I'm going to look at a bit about what's involved in engineering a good system on 23 sems. And I'm mainly going to talk about terrestrial stuff, but I will mention moonbounds briefly. But I have to be careful what I would say about moonbounds, because Peter G3LTF's here and he knows more about it than I ever will. Okay, there are 3 big myths about the gigahertz band, and it drives me nuts when people come up and say, oh, this, that, and the other. Right in the gigahertz column, I tend to get lots of emails from people about how to start and what do I do. And one of the things that comes out, there's sort of 3 big myths. Well, they're all line of sight, aren't they? You just go on a hilltop and talk to the bloke on the other hilltop. And I've been pressing to get the intermediate syllabus changed, because it talks about the gigahertz bands being line of sight, and I'm trying to sort of change that a bit, because they're not. Simple as that. People say, oh, it's expensive, Yagis, dishes, transverters. Oh, no, that's not for me. And it's too technical. These guys are talking about noise figure and ERPs and JT65, and I think, I'll stick to my 160 meter dipole, working lots of DX. You know, things are good. I can put up a piece of string in the back garden. It's all a bit technical. So they're the 3 myths that I want to try and get rid of, or at least tackle anyway. It's not going to be everybody's kettle of fish, these bands, but I think I get a great deal of pleasure out of them, and it gives me amateur radio that I wouldn't normally get from my site. So, myth number 1. It's all line of sight, and you have to live on top of a hill, and you've got to be like Nick and have a 60-foot tower in your back garden and be able to see the sea and Manchester at the same time. But it's not. You don't. It's fantastic if you've got a site like that. You will have the time of your life, but it's not like that. So I'd like to introduce something to you. I'd like to introduce the G4BAO whole. This is a terrain map of the UK, and at the end of that big red arrow, pale blue means it's at sea level roughly. And Colin will appreciate this, because Colin's on that little high bit just there. But I live in a hole. I'm 4 meters above sea level, and if you compare that with someone like G3XDY who lives on the coast, he's at 34 meters above sea level, and he's on the coast. I'm 4 meters above sea level. My antennas are 8 meters above ground, so my antennas are 12 meters above sea level. And I recently won a UKAC 23 SEM open section. So you can do from a particularly poor site. You'll see I'm surrounded by hills. The only reasonable takeoff I've got is across the fens, because some of those bits are actually below sea level. So I get up into OZ, but I've got G4BEL who sits on a ridge to the north of me at Hadnam, and I have to beam through him even to get up to Nick in Bishop Auckland. But from that site I can work a well-sited 10 gigahertz station up in Bishop Auckland, and I can work regularly into Germany on 23 SEMs. So you don't have to live on a hilltop, you can live in a hole. And this is This is my squares map since I started. That's what I've worked. That's my terrestrial squares map. I've worked 81 squares and 20 DXCCs on 23 SEMs, mostly with just 35 watts. I've only recently got a big amplifier. I'm from a hole in the ground. So you can work some interesting stuff. My best TX is this guy, LY2WR. And I've also worked up into the Faroes, and I worked up into Shetland. And if you add my small moonbound system, I've actually worked 125 squares throughout the world and 38 DXCCs so far on 23 SEMs. So you can do it from a particularly poor site, but I've had to put some serious engineering into my system because I don't have a tower. I have an ordinary suburban house with a couple of poles on the side of the house, but sort of forced into it really. So it's not all line of sight. You can work some nice DX around Europe if you get the conditions. It's really expensive. That's the second one I hear. Well, this was done before the pound crashed a bit, but you can buy one of these things, which is a 2-watt 23 SEM transverter, 2 meters in, 23 SEMs out. They're about 165 euros, so that's probably about 165 pounds now. A single ton of Yagi and a bit of coax will cost you just short of 100 quid. So you can get a basic system together for under 250 pounds, right? If you want to add a preamp kit, you can go see Sam and he'll give you a preamp. Well, he'll sell you a preamp. You can get a PA kit from DB6NT and a number of people for around the £100 mark. Surplus coax relay, waterproof box to stick it all in, and you've got a seriously competitive system there for 440 quid. That will work most of what you want to work on 23 SEMs. Now, that looks like money, but let's just do a little comparison. Let's just compare it with getting going on D-Star. You go out and buy yourself a D-Star handheld in the base station antenna. That'll cost you £100, just £100 short of getting on 23 SEMs. And you know, in terms of interest, if you want interested in the technical side of the hobby, I think you get more fun out of 23. Decent walk band setup. A Cushcraft beam will cost you over 500 quid for a decent walk bands beam. If you just want to do wideband scanning, a FunCube dongle and a Diamond Disco will cost you 250. So we're in the same ballpark for getting a good, reasonable system on 23 SEMs. So it's not expensive. It's not expensive compared to the rest of the hobby. When you think what people spend on some things, it's not hugely expensive. This, of course, assumes you have a 2-meter driver because this is aimed at sort of 2-meter DXers. So I'm assuming you've got something for 2 meters. Is it too technical? Well, no, it's the same as 2 meters. You have a transceiver, a piece of coax and a Yagi. Or you have a transceiver, a transverter and a Yagi. So in terms of technical complexity, just to get going on the band, it's not horrendously difficult. If you can go on 2 meters or 70, you can work 23. So that's hopefully giving you some view of my views of these myths. So I said I'd say what's the same and what's different. Well, you can still use Yagis at 23 SEMs. You don't have to use dishes. And in my humble opinion, I think the propagation on 23 is actually slightly better than VHF in terms of for a given site and a given size of antenna. So you can work some interesting stuff even with there. What's different, and this was the killer for me, there's much less band noise. If I look at my band noise on 4 meters as my worst example, very simple test to check for your band noise is disconnect your antenna and put a 50 ohm load on your preamp or on your input to your receiver and see how many dBs your noise level goes up. On 4 meters, my noise level goes up 26 dB. So that means if somebody's running, if I'm running 1 watt and someone can hear me, they have to run 400 watts for me to hear them. So it's slightly better on 6, but on 23 SEMs, there's one direction which is towards the local TV transmitter where my noise comes up 1 dB. So you're in much less band. If you've got a noisy VHF site, try that. Tropo scatter and aircraft scatter, a lot of VHFers have done. It's much, much better on these bands. Tropo scatter is very close to the sort of frequencies that the professionals use. So with a reasonable system, you can work 500 kilometers every day on these bands, either by tropo scatter or aircraft scatter. So better propagation, in my opinion. This is another one, if you live like me in the middle of a housing estate. Very low visual impact antennas. A reasonable size 23 cell antenna looks like a TV antenna, and in fact it's smaller. So you can pop a 23 cell antenna and a preamp box and a rotator on your chimney, and people will just think it's a TV antenna. Dishes become practical at this frequency. You can actually, and that gives you a little into the higher bands, because once you've got a dish there, you can use multi-band feeds on the same dish. There's a company in Holland that make a tri-band feed for 23, 13 and 9, and they also make it for other combinations of bands, so you can put a dish up and it doesn't have to be that big. I'll have a look at typical comparisons between dishes and Yagis later. There are fewer black box solutions around. You can buy a TS2000, you can buy an ICOM that has 23 SEMs. There are a few standard ones. You can buy a plug-and-play transverter, but there's a lot more silver box solutions. There's a lot of people making kits and making things that go in these lovely silver tin-plated boxes, which you can build yourself with a bit of practice. And there's quite a few of these around. There's a company in the US, Down East Microwave. There's DB6NT. There's a company in Australia, Mini Kits, who all make kits for these bands. So if you want to build your own, you can do it. And they're not that difficult to build. You've got higher gain antennas. You can generate higher effective radiated powers. If you've got a certain length of Yagi on 2 meters and 400 watts, that's your output. It's power multiplied by gain. You've got something like this, which is not that much longer than a decent Yagi. You can get huge ERPs. The ERPs on 23 SEMs are often measured in kilowatts. So you can really generate power in one direction very well. And that makes small dish and big Yagi EME possible, practical with JT modes. If you want to jump up to moon bounce, I don't know whether Keith G4FUF's here, but he works JT moon bounce with 4 Yagis on 23, and also G4BRK runs Yagis, and he has JT EME contacts, quite good ones, and I have EME contacts with a 1.9 meter dish on this band, on CW and on JT. So small dish, big Yagi, EME becomes possible. The only thing you've not got on this band is Spreadicky, which is a shame. I'm a great fan of Spreadicky. It's very exciting, and 4 and 6 in the summer, but not on this band, I'm afraid. It's just too high in frequency, and no meteor burst either, unless you have an EME system at both ends. There have been meteor burst contacts on 23, but boy, you have to have a big system. So, on the subject of propagation modes, what do you actually get on this band? Well, tropospheric enhancement and ducting. You're all aware of that on 2 meters and 70 and the other bands. This weather-dependent thing, up to 2,500 kilometers, typically you can work. You have a big advantage near the coast, and I think Peter will correct me on this, but you get a bigger advantage on the higher bands with coastal ducting than maybe you do on 2 meters.
Probably.
Yeah.
You need John XTY, really.
Yes. Yeah. So if you live on the coast, it's also a no-brainer to have a go on these bands, because you get very reliable propagation. One of the banes of my life is German stations coming on to KST and saying, well, I can hear G3XDY. He's in the same square as you. And I've got the function key on my computer that says G3XDY is 80 kilometers closer to you, and he's on the coast, and he's 25 meters higher than me. So it's a big advantage if you work on the coast, but you get the tropo conditions, you can work that sort of distance. I've not got close to that yet. 1,600 and something working LY was my best. But it is possible to do some quite good DX on these bands. Aircraft scatter. This is becoming more and more the done thing on 23. If you look at G3XDY's results in UK ACs, you'll find that all these big distance contacts up to Sweden and down into Germany are all on aircraft scatter. And it's very easy to do with CW. You can do it with SSB, as Neil and I have done this on 10 gigahertz many times. We've done aircraft scatter on 10 gigahertz. I won't embarrass him by saying why we use SSB, but it's possible. It's possible to do aircraft scatter on these bands, and you can do it with JT modes. I've worked GM0 USI on 10 gigahertz using aircraft scatter using JT modes. So. It's very good, and I'll show you a movie later of a beacon with aircraft scatter on it, and you'll see, because you've got more Doppler at these high frequencies, the aircraft scatter, you can see it much better on the spectrum display. So aircraft scatter is very important now, and we'll come on to the sort of station you need to do that. Troposcatter is, well, just there every time, really. That's not to be confused with tropospheric enhancement. Troposcatter is just using the randomness of the troposphere to forward scatter signals off the lumps effectively in the troposphere, and you can regularly work sort of 500 kilometers with a decent high power station on this band. So and it's easier to generate those ERPs on this band than it is on 2 meters. And EME. When I started amateur radio, EME was something incredibly exotic that nobody could do. And much to the chagrin of all the guys who've spent years and years putting huge systems together, it's actually got easier now because technology is there. Joe Taylor is with Joe Taylor you either love him or you hate him, unfortunately, but we won't even go into that discussion. But the JT modes have made a big, they've introduced people to EME. And they introduced me to it, and I suddenly found I could work people on CW as well. So I do a mixture of both with a small dish. So this is where you'll have to listen very carefully when we have the sound on. This is a recording made of LY2 to WR at a long distance. So listen, this is extended tropo. That's a sort of strong, that's a sort of a good tropo signal. I will stop that thing there because I have to tell you something which is funny. When I found this clip on YouTube, I listened to it all the way through, and I can play it later. And right towards the end, this guy's calling CQ, and some idiot comes on top of him and calls him. And I listened very carefully, it was me. So, just to prove I was there when he was on, but he started, because these signals come up and down, you can see the sort of signal you might see on a waterfall display with CW. Oh, sorry, I stepped out of the box. And that is a typical extended tropo signal. You'll get them much stronger than that. When I worked GM40DA, who was up in the Shetlands earlier on this year, it was a sea path right up from East Anglia to the Shetlands, and this guy was 20/9. Nick was 20/9 on 10 gigs at the same time. So you do get some very strong signals, but that's quite a good distance, 1,600K on 23. You're pretty good if you're doing that, but as you'll see in a minute, there are better ones than that. This second one with sound, this is aircraft scatter. This is just a still of GB3MHZ, the beacon at Martlesham, and you can see the main carrier, and you can see it keying, doing frequency keying, and that horrible squiggly line either side of it, those two squiggly lines, are aircraft reflections. And this is a particularly good picture because this one goes all over the place. So I've actually got that live with sound if this works, but my computer's rather slow, so just bear with me for a second. Hopefully the sound will appear in a minute. Hang on. If it doesn't, we'll move on. It's just that this is a 111 megabyte WAV file because it doesn't. This thing doesn't support MP4 being Windows XP. No, let's leave that one. Let's just move. Oh, hang on. Right. If you listen very carefully, you can hear the other tones. You see that bit there? That's the main signal. These are two aircraft peaks. Okay, that'll just give you some idea. That was a recording of GB3MXZ was beaming over Heathrow at 90 degrees to it, so you could hear the direct signal off the side of my antennas, and you can see the aircraft as they took off from Heathrow. These are the current records for 23 SEMS, and I was amazed when I saw how old these are. Where is everybody? Surely somebody's going to break these, but 2617, which was G6LEU down to the Canaries in 1989.
It was actually before 89.
Hmm?
It was before, I think it was before 89 because I broke the record with the XS on 70 around the same time. It was 84 actually.
Oh, okay. Well, that I will check on the. I shall check because these were lifted off the UK Microwave Group's website, so it could be earlier than that. But that's a hell of a QSO. The world record is from Hawaii to Mexico. That Hawaiian path, that Pacific ducting, all these are on tropo ducting. And just for completion, the EMI record I think still stands from 90. No, Peter's shaking his head.
I think it's VK3UM to DL1YMK/CT3.
Oh, that's been broken, is it?
They're almost exactly antipodal points, I think.
If you can confirm that and drop John Quarmby an email, because this is what our website says. But it's basically as far as you can get on EME. I'd just like to point out it wasn't done with one of those Yargis. That's one of Kent Britain's WA5 VJB's quick starter antennas, piece of wood and bits of wire. They work remarkably well. Great for a disposable antenna. So DX is possible. I don't think anybody in Europe is ever going to come close to that world record, unless somebody manages to work right down the coast of West Africa from Cornwall. But that's a hell of a thing, that is. They've just recently done a California to KH6 record on 9 and 13 recently this year, I think. So these bands you do get mega DX, but you have to be in the right place at the right time, I think. Right. It's all about systems engineering. I'm getting onto the detail of what I wanted to talk about now. It's all about. I think this band is all about systems engineering. Peter described Moonbounce as a experimenter's playground yesterday, and I thought that was quite funny. But this is the same. If you want to experiment with stuff, you can optimize systems. And its antenna performance, its system losses, its receiver performance, signal handling and noise figure, and how much power can you generate. Life's too short for QRP, as we all know. But this was a system I had up a while back. You probably recognise that was on the front page of something. That's 23 SEMS plus 13 SEMS on a single pole. And I actually left the chimney in there on my QSL card. I've photoshopped that out, but that'll just give you a perspective on size. So that's a high performance 23 SEMS plus 13 SEMS antenna. So, as I said before, high gain and small antennas are possible and practical. You take a 3-meter boom length Yagi, which is a moderate size antenna on 2 meters, you'll get 13 dBi roughly. give or take. I don't want to go into arguments about different designs, but roughly 13 dBi for a 3 metre boom Yagi on 2 metres. You have the same boom length on 23 and you get another 7 dB. So that's like adding lots and lots to your power. That's what, 10? 7 dB is 5-6 times. Yeah. So that's like buying a linear. So straight away you've got this ERP advantage on 23 SEMS over 2 metres. You can point more in one direction. Typical 1.2 metre dish, which is not particularly that big, that'll give you 23 dBi. So you can get 10 dB more gain going to a moderate sized dish. And I say the great thing about these small dishes is you can add extra bands later. This is my 1.9 metre. Ignore the rotator. That was my first attempt at it. But that's my 1.9 in the back garden at ground level. I wouldn't want to put that on my house. I think I might upset a few neighbours. But 1.2 metres is not too bad. So you can get lots and lots of ERP. A single 28 element Yagi. Anybody who was up at the judging of the construction contest yesterday, there was a 28 element Yagi up there on, and I kept poking my eye out with it, so I put it on the floor eventually, but it's smaller than a typical TV antenna. A typical digital TV antenna now is much bigger than a single 28 element Yagi. And a 28 element Yagi is somewhere between 13 and 20 dB. I can't remember the exact figures, but it's a serious antenna. Oh, there you go. It's 1.6 metres long, and you'll get 17 dBi. So you'll get 4 dB more than you'll get on 2 metres, and that's half the length of that Yagi. So you can generate some nice ERPs, and they look like this. You can go to Germany and buy one. You can go onto Kent's website and build one out of wood. And if you're going portable, that's all you need. It doesn't have to be weatherproof. So you can build a nice antenna for that. So that is one of the crucial things. You've got to really work on this antenna. The other thing, the second thing, is loss reduction is the king on these bands. On HF, you're really not that bothered about feeder losses. But once you get to 1.3, RG2 and 3, which is your average HF feeder, 3 dB for every 10 metres. So for every 10 metres of feeder, you lose half your power. FSJ 450, which is the professional Andrew hardline, is about 1.35 dB per metre. And I was staggered to find out that the M&P Ultraflex is actually better in terms of loss. So you can get down to 1.2 dB per 10 metres without spending a huge amount of money. But that's still, if you have a 20 metre feed from your house to your antennas, you're still losing nearly half your power, even with good stuff. So we have to do something about it. And what we do is the bigger stations will use Masthead preamps and big power amplifiers to get their losses down. And this important word is Masthead, because we'll see why later. And that, which is this, that's a combined Masthead power amplifier and preamp built by Gavin M1BXF for cam hams. It sits underneath the Yagi on the boom like that. It just has power and 2 connectors, one marked radio, one marked antenna, and that's a 50 watt amp, complete with all its heat sinking and a very low noise preamp and a bit of switchery. And you can see what's inside of it, and there it is reading 35 watts or whatever it is. So something like that is pretty light. I've got something similar on my mast, and you can put that on a 2-inch pole and have a bit more coax, and you can get small high performance stations, and with 50 watts and decent preamp you are flying on this band. There's all sorts of clever things you can do. One of the things I've done is you can run 2 bands at the masthead. You can run multiple bands with 3 relays and 1 piece of low loss feeder. All my systems, I don't use the same feeder for transmit and receive, because I use cheap 1/4 inch coax on receive, So what you can do is you could have a box with a pair of Masthead preamps and 2 antenna connections, 2 relays. You can combine the 2 bands passively down the receive feeder and split them at the bottom end. And you can have a separate one going to your transmit side to your PA. And if you think about it, if you use 1/4 inch coax for one and decent stuff on the other, it's no much bigger than a single piece of hardline when you tape it all together. So I always do that, and it makes it easier to do the switching. You need fewer relays, and they tend to be a little bit pricey compared to some. So there's all sorts of things you can do to get these losses down, but why can I get away using cheap coax on receive? Well, we'll see. And because we've got to determine whereabouts in your system design these losses are crucial. Transmit loss is easy. You just build a bigger amplifier or put your PA closer to your antenna. So there's nothing really complicated about it. It's just pure brute force and ignorance, that one. But how do these losses affect your receive performance? And they are actually a little bit more subtle. And I'm going to do something a little bit of technical stuff now. I'm going to talk about noise figure or noise factor, which is a measure of your receiver performance. And it's the signal to noise on the input minus the signal to noise on the output in dBs. That's all your noise figure is. How much extra noise does your system add to your signal? Input signal to noise is determined by where your antenna is, what type of antenna it is, what its side lobes are like. So Justin spent a huge amount of time doing low noise antennas, not for 23 unfortunately, but you need to get an antenna with a nice clean pattern so that you're not picking up noise. But it's determined by the antenna's environment, what it's seeing, where it's pointing. Is it pointing at the horizon? Is it pointing at the sky? Is it pointing at the next door neighbour's tree? And the output signal to noise ratio is just determined by your system noise figure. So you can affect both those in very subtle ways. You can affect the first one just by getting a better, cleaner pattern on your antenna. You can't do anything about the noise that's actually picked up. But you can go ahead and improve your noise figure. But anyone who went to the talk yesterday about transceivers will know that noise figure is not everything. And I've sort of left that side of it to him, but I'll mention it briefly. But system noise figure, I'm going to talk about noise factor to start with. The only difference between noise figure and noise factor is noise figure is 10 times the log of noise factor. It just makes it easier to show this. So there's a typical 2-stage system where you've got a preamp with a certain gain and a certain noise figure, and you've got a receiver with a certain gain and a noise figure. A typical 23 SEM system, Masthead preamp, bit of coax, second stage. The overall gain of that system is the two gains multiplied together, or added if you've got dBs. Okay? Okay so far? Now, the overall noise figure is not quite as straightforward as that. This is a thing known as the Friis equation. It's a Danish American who worked at Bell Labs came up with this. The overall noise factor for, just ignore that bit at the end first, for a 2-stage system is the first stage noise factor plus the second stage noise factor minus 1 over the first stage gain. Right, so just ignore that bit. So what that tells me straight away is the bigger I make that first stage gain, the smaller that term becomes, so the smaller my overall noise figure becomes. The first noise figure is fixed, but the second one is determined by the first stage gain. So if you've got a low gain preamp, you'll get less improvement than you have with a high gain preamp, and it's very easy to show that. So the second stage contribution, that F2, is mainly determined by the first stage gain. Now, I think you may be beginning to see what I was talking about before. Here's a typical example, an ultra low noise preamp with 0.3 dB and 26 dB gain. If you convert those dBs into numbers, you're talking about 401.07 for gain and noise figure. A TS2000, a generous measure of its noise figure at 23 SEMS is 7 dB. And we're not interested in the second stage gain there, just the noise figure. So we've got First stage noise figure 1.07, second 5, first stage gain 400. Plug those numbers in and you get 1.08 dB, sorry, 1.08, which you confirm that into dBs is 0.33 of a dB. So that first stage, that second stage contribution has only added 0.03 of a dB to the overall system noise figure. Just 0.03 of a dB. So what we're really saying is that first stage preamp, if you've got enough gain, sets your system noise figure. If you drop the gain of that preamp, let's just go through those numbers again with a 12 dB, a single stage preamp maybe with 12 dB gain. Same noise figure, but we've got a gain of 16 rather than 400 now. If you plug those numbers in, you end up with 1.32, which is 1.2 dB. Now look at the difference. We've gone from 0.33 of a dB to 1.2, and that's all the second stage. So that second stage has now added 0.9 of a dB instead of 0.03 of a dB to that thing. So preamp gain, a higher gain preamp, up to the point where you start to overload your receiver like they were talking about yesterday, you need to get that gain high to gain the factor, the benefit of your low noise figure. That's why EMI preamps have got huge gains, and we'll see why they can get away with that later. So let's just do this calculation this time. Let's just put some loss in front of the preamp. And that loss can be coax, relays, and things like that. So I'll put half a dB of feeder loss in front of my 0.33 dB preamp. This now we've got a three-stage thing. So if we run that formula again, it's the first stage plus the second stage minus 1 over the gain, and the third thing now is the second stage noise, third stage noise figure minus 1 divided by that gain multiplied by that gain. So this is getting smaller and smaller, but we've got a passive loss of half a dB in front of the thing, and that works out with those numbers. I'll leave that as an exercise for you to do. But what we end up with is an overall noise figure of 0.83 of a dB, and if you remember, in the perfect situation we had 0.33. So what's happened is that half a dB has just added directly onto the front end noise figure. So if you buy a 0.3 dB preamp and stick 1 dB of feeder loss, you'll end up with a 1.3 dB noise figure preamp. So don't do it. This is why people use masthead preamps rather than preamps in the shack. You put the first stage as close as possible to your antenna to minimize that loss. So if you can get that down to 0.2 of a dB, which is a typical relay, you'll end up with a noise figure of 0.5 rather than 0.3. So the half dB feeder loss just adds directly on. Now, if we move that loss after the preamp, and in practical terms that'll be a lot more than half a dB if you've got coax there. But if you do the same sums again with this now the first stage, second, third, you end up with back to about 0.3 again. So any loss after the preamp doesn't really affect things. So that is why people use masthead preamps. No other reason. You can have this is why I can get away with RG58 as a 23 SEM receive feed, because I can have 10 dB loss in there and it'll hardly affect my noise figure because I've got plenty of preamp gain. You can do the sums, but that's masthead preamps. That's why people use masthead preamps. And how important is this noise figure? This is a lovely piece of software that was worked on by VK3UM and Peter G3LTF and a number of other people. This is a system calculator. It gives you can stick in you can still in your gains, noise figures, preamp losses, and it pops out at the end a total noise figure, and it also pops out your system sensitivity. What's the weakest signal you can hear? And it's a really useful tool, and it's free. You can download it from vk3um.com, have a play around with it. You can do all sorts of what-ifs with your system on that. But what's very interesting is I've just been talking about preamps. I haven't been talking about antennas yet. What's the effect of the antenna noise? What does this do to how good our preamps are? Sky temperature, it's known as. If you take an incredibly cold sky, I think 10K is probably a bit even too low. It's probably close to 150 on 23 SEMS. But if you take a low, quiet sky, so you point your antenna at the sky, if you work in satellites or you work in moonbounds, when you point your antenna at the sky, there's very little noise compared to bringing your antenna down to the horizon. Anybody who's done 2-meter EMI with elevation will know that when you lower your antennas, you can see the noise come up, and that's purely because the ground is hotter than the sky, and the amount of noise that it sees is proportional to the temperature. If you put all those numbers into the VK3UM calculator, that number minus 142 dBm pops out as your absolute sensitivity, minimum sensitivity, maximum sensitivity. If you drop the noise figure to 0.45 of a dB from 1, you don't just get 1 dB improvement in noise figure, you get 5.5 dBs improvement in noise figure. Magic. That's when the antenna's pointing at the cold sky, and you can run all these numbers. So this is why EMI people spend so long getting low noise preamps, very low losses in front, low loss feeds, quiet dishes, because when your antenna's looking at nothing, you really get the improvement of these noise figures. Plug in the same numbers for a typical horizon temperature at 294 Kelvin, ground temperature. For exactly the same change in noise figure in your preamp, you only get 1 dB improvement. So if your antennas are pointing at the sky, you can work like mad and get your noise figure way down. But if you're pointing at the horizon, it's a sort of a diminishing returns. So I like to aim for about 1 dB noise figure overall on terrestrial systems, and you can get that with a half a dB or less preamp. But you don't have to go for the most ultra low noise on terrestrial systems because it's a law of diminishing returns if your main source of noise is the sky. Okay, so I like to aim for about 1 dB overall, if I can do it. What contributes to, so the contribution to that noise figure, minimize your losses in front of the preamp. We've seen that makes a massive difference. So that also means if you put a filter in front of your preamp, any loss in that filter is going to add directly onto your noise figure. So if you can get away with it, don't put filters in front of your preamps, but you may have to. Higher gain in the preamp is a lower second stage contribution. We've seen that. You can use cheap lossy receive feeders on 2 feeder systems, and that's a good way, I think. But you've got to watch out for first and second stage overload. The talk yesterday on VHF transceivers covered this extremely well, so I'm not going to do much on it. But it's a compromise between getting a reasonably low noise figure and stopping the rest of your system overloading, because if you live next door to a large TV transmitter, and just to give you a good example, Tony G4MBS lives on the local hilltop. He can see Sandy Heath. He gets heck of all noise on 23 SEMS. I live down in my hole and I can't physically see Sandy Heath, and I get about 1 dB increase when I point in that direction. So if you have to put filters before your preamp, if your preamp is overloading, you need to do it with incredibly low loss. So after the preamp, if it's at all possible. So that's my whistle-stop tour of receivers and systems engineering for receivers. Transmitters is a little bit simpler to cover, really, and these are very general comments about what's good. If you run 1 to 10 watts on 23 SEMS, you'll work all your locals, you'll work some of the big stations, you'll work nice Tropo DX in lifts. For a long time, my best DX was into SM, and I worked that with 4 watts on 23 SEMS to a single Yagi. It's simple, it's cheap, There's no external switching. There's no external switching required or specialist components. That sort of power. Go up to 5200 watts and you can really do aircraft and troposcatter very well. And you can start to work this 500k. You can work JT EME with a 2-meter dish with this sort of power. And when you get up into the 400 watts, not only do you light up your local PIR lights outside when you go on, which I do, you can do aircraft troposcatter really easy, and you can do CWME with a 2-meter dish with this sort of power very easily. You can work PT, you can work a lot of people, and you can do JT with 2 Yagis with that sort of power quite easily. So, but you do need to take care with this sort of power. Once you've got one of these, which is one of the 500 watt bricks from our friend SM4 DHN, you've got to be quite careful. You've got to watch out that you don't have loose connectors. I've seen fried end connectors at this sort of power. You do not want to stand in front of your antenna when you're transmitting. You can get some serious RF burns off this. So, and you also need to very carefully protect your preamps, because up to this sort of power you can very easily blow up preamps. So that's it really. So just to sum up, with 5 minutes to go, don't believe all the myths people tell you. 23 is a great band for what I like to call covert operation. Small antenna, nobody even knows you're on the air if you put a single Yagi up for 23. It's a great band for a noisy VHF site. In general, it's pretty quiet, but it's getting noisier. And sight is not everything. Yes, if you have a site like Nick's or like Dave's, you will work loads and loads of good stuff. But you can, with good system engineering, you can do some good stuff from a very average site like mine. And if you've got an awful site, you can always do EME from your back garden with a 2-meter dish. It's not that difficult. So, stress it again, I think system engineering is everything in this. Keep your losses down. Losses between the front end and the antenna. Use a Masthead preamp. They're almost compulsory on 23 to get decent results, but you've got to avoid overloading from in-band and out-of-band signals. Use a receive filter after the preamp if you can. Think about dual feed systems, and then the other good thing about dual feed systems, it's easy to split off the receiver to SDRs and second receivers and things like that. And on the subject of SDRs, you really need a band spectrum display on this band, because activity is not huge, but I find it's fantastic in contexts where you can just find where people are. Rather than having to tune, you can just look a whole 190 kilohertz of the band, and you can see that. So, if you want to find out more, search the internet, buy some books, visit a microwaver at home, you'll be very welcome. Go and knock on his tent when he's standing on a hilltop. We've got, this is the plug for the UK microwave group now with 2 minutes to go. We've got a Twitter feed, we've got a YouTube channel showing what we're doing in microwaves, loads of books. We've got a website, microwavers.org. We've got nearly 450 members. It's still only £6 a year. I've been treasurer for God knows how many years now, and it's still only £6 a year. We've got a chip bank, free, not even postage, surface mount components. We've got a monthly e-magazine. We've got loan equipment for all the higher bands. We fund beacons that have any microwave content. We'll support clubs. We have talks and things. And if you want to find your local committee contacts, see the UK Microwave Group website. Oh, and we host roundtables. Okay, that's it. We've got a few minutes left for questions, but I think because I started late, if we have lots of questions, let's just overhang a bit. No, I mean overrun, don't I?